Okay, so in this video, we're gonna quickly go over different features of the source that we can use, and mainly because I want to be able to now talk about transformers, the perhaps the have a look at the saturation, how the voltage drops, um, how the different losses across the transformer gets impacted. So I want to have a capability to be able to change the voltage during the simulation. As you can see right now, when I started the video, the simulation is running in between, but if I wanted to be able to change the voltage, which is 230 kV coming out of this source, there's no way that you could do that. You would have to stop the simulation and then change the voltage. So, but it worked out pretty good. All I did was, initially we went into master library, into more on sources, and this right here was where it was sitting. We brought it into we copy pasted it, and all we really had to do was come into signal parameters and set this to 230 and set up 100 MVA base, and at the terminal, and everything else, kept the same, and everything was ideal. I knew that we're going to get 230 kV RMS, right at the terminals of this source, and there's nothing else that you had to populate. But now I just want to be able to dynamically control this 230 kV. And one easy way to do that is if you double click this and you come into signal parameters, instead of saying specified parameters at the terminals, we do have to then say behind the source impedance. So what that means is simply that, behind the source impedance, if I press OK, one thing that popped up is a frequency and voltage, and that's mainly because if when I changed it to behind the source impedance, and before it was at the terminal, these two options weren't available. So if you go to behind the source impedance, it says external control of the voltage. You want to be able to have that. If you have that as yes, interestingly, if I just said no, you can see that it will actually still go away. But these two options only become available if you are using the option called behind the source impedance. So I'm just going to say yes, and I'm going to say yes here because I want to be able to control the frequency or the voltage externally, and we're going to set it up in a way so that we can actually change them during the simulation as well. And what behind the source impedance really mean is, if I now go into to impedance, or can go to configuration, says source impedance. If I now, let's say, click in, this is inductive, so this source, and press OK, you could see that, it would add essentially an inductor over here, and then we can then specify the impedances as well. So behind the source, if you have some sort of an impedance, you may not then get a 230 right at the terminal, but this particular source will be given out 230, but then there might be a bit of a voltage drop across the source. And in reality, we would have sources, there is a bit of a source impedance, which is the reason of modeling this. But again, we're not going to get into this. This is a very basic series. I just want you to have, I want you to get comfortable with the environment. So go into configuration, just set this to ideal. All we just want is a good or pure 230 kV right at the terminal. So I'm just going to press OK, and you can see there's not going to be any drop across once this source is going to create a 230 kV. But you can now see created to voltage. There's two arrows that are basically being pointed, and it basically means that we can connect something to this. What that means is, if you again double click this and go into help, and I'm going to help and click this, Pscad helps buttons are actually very useful. And right at the first screen there, when you click help for this component, it defines that. It says this source may be controlled through either fixed internal parameters, which we were using internal parameters before, or variable external signal. So external is no longer in the properties, is outside, and is variable. So it's not even fixed, but actually we will be able to move it as well. So if you wanted to give it a fixed, we could do a fixed signal. What that means is essentially if I wanted to give it, perhaps a direct signal like that, I could do this. Like I could say, hey, 60 frequency, and it would be fixed at a 60 frequency. If so, you know what, just for the sake of example, I'm going to keep this as fixed at 60. And then what I want to show you is I want to be able to also get 230 kV, and you will see that I may not be able to get a 230 kV just yet. And how about, we've got some graphs here already. I've got the power, and so power through this meter, Q through this meter, and then the voltages through this meter are also being graphed over here. So voltage line to line RMS source, that's coming out of this meter. So how about I run this for 1 sec, and you will see that even though I'm saying give me a 230, I may not get a 230 just yet. And I'll show you why and how we can fix this as well. And we can kind of go through these little exercises so we can get more comfortable with utilizing different techniques to give Pscad what it really wants. So let's start. So it's finished compiling here, and as the simulation starts, there we go. Okay, so you may notice something over here. It says, you know what, I'm just going to turn this off. So V line to line RMS is actually now at 281 rather than the 230 that I'm given it, right? So if I bring you back to the help, and there was something important that it did mention, it says this is a voltage line to ground peak voltage. So not only that it wants the it wants, so if you want the so let's do a quick calculation here. So let's take that. So if I want a 230 kV, so this is 0 when I'm saying 230 kV. That's basically the line to line RMS value I'm talking about, right? So that's generally just a little, it's kind of like the equivalent, the DC equivalent of our AC circuit. So so that's the value. And generally what's that equal to? If you wanted to 30, then the peak of that is voltage RMS times the root 2, which in this case would be equal to 326.6. And again, this was line to line. But what they want a line to ground and a peak. So if I wanted a 230, if I want this source that I'm using in the back here, if I want this source to give me not 281, but if I wanted to give me a 230 line to line, what the value that I really need to enter is essentially 233, which is a line to line, divided by root 3. So that will give me a voltage line to neutral. And that's going to be 230 divided by 1.73. So that's about approximately that kV, right? But that's still just a line to neutral. And when we looked at the instructions, what did it say? It basically said that we need the peak voltage. So first we got the line to ground, and now we need a peak voltage as well. So I'm going to bring it back over here. Oh, I had the instructions here too. So peak voltage. So I've got the 132.9, but this is line to neutral. But that is still RMS value, right? Because this was 230 RMS, like this was green RMS that I took that over there. From there, I've now got this. Now I've got the RMS, but now I need to multiply it by root 2. So I've got 132.9 times the root 2, and that's going to give me 187.94. So let's try that, 187.94. So I'm going to stop this. 187.94. Oh, that's a good practice as well. If you go into components here, you can see I'm using a blue constant, and that's actually is just an integers that it can take. That's what's the error. So I gotta now come back and actually use the green one, which is right underneath here. And that constant now is a float, or you can enter in the decimals. So 187.9, 187.90, and then now let's just run it, and then that should give me now this source is set up in a way that it can convert the signals so that it can generate a 230 kV line-to-line RMS. So let's have a look at that quickly. So finish compiling, and here we are. So now we are getting, 230. So we are now getting a 230.12956, which is great. But it's not entirely exactly giving me that, right? So it's giving me 230.129. So what can I do to do all this math, which was divided by root 3, right? And then multiply by root 2. So we can, and also I want to be able to change the value as well, right? So the way we could do this very easily is this.